like to introduce our first presenter. He's going to talk about influenza and swine flu, Peter Palese. He is the chairman and a professor of the Department of Microbiology at Mount Sinai Medical Center here in New York. Please welcome Peter Palese.
I would like to discuss briefly influenza viruses and the disease which is caused by these viruses. So the virus is an RNA-containing virus, so it has its genetic information RNA, and if you look at this particle, it has 8 RNA segments. So there are 1 in the center and 1, 2, 3, 4, 5, 6, 7 RNAs. These are like mini chromosomes, which are the genetic information of the virus. This virus also has a very important characteristic, and that is it has on the surface, it has spikes. And one can see this in this electron micrograph. There are spikes associated with this virus on the surface, and that's actually what the immune system, when we get infected, sees. These surface proteins are called the hemagglutinin and the neuraminidase. So these are 2 proteins, hemagglutinin and neuraminidase, which are on the outside. We should also understand that the virus is very, very small. A cell which is infected by this virus is much, much larger, not only larger than this room, but it's probably as large as the Empire State Building. So we are really dealing here with a very small entity, a very small virus, which can, within 8 hours, infect a cell and kill this Empire State Building and make about 100,000 new virus particles. So this is the virus which can cause the disease. In humans, we know that there is influenza every season. In the northern hemisphere, it's from November to March about. And also, many people know that a hallmark of the virus is that it changes. And if we look here at the different viruses, influenza viruses, which have circulated in the last century, we know about the 1918 virus, which was, in terms of number of deaths, a very important historic event, because within about a 3-month period from November 1918 to about February of 1919, in the US alone, about 750,000 people died. So this virus, 1918, belonged to what we call the H1 subtype. That means it has a hemagglutinin of this H1 subtype, and this virus was replaced in 1957 by a separate virus, a different virus, which had a hemagglutinin 2 subtype, and that subtype was prevalent for about 11 years. And then in 1968, a new subtype emerged, an H3 virus, which is actually still with us in 2009. In addition to this, there was also in 1977 another H1 virus reappearing, and it turned out that it was very similar to a 1950 strain. So in 2009, we have H1 viruses, we have H3 viruses circulating, and then in addition, also an influenza B virus. So the complexity of influenza is quite impressive, that we have these co-circulating strains. And that explains why, for example, vaccines, which are very helpful. They are not perfect, but they are a very important way of preventing influenza. Why vaccines have to have 3 different components. So for the last season, that means 2008 to 2009, we had in the vaccine formulation 3 different influenza virus components. We had the H1 component, and this was an isolate from Brisbane, isolate number 59, and isolate in 2007, an H3 component, and a influenza B virus component, isolate in 2006. Now, that would be all very good if we could use this vaccine for several years. But unfortunately, influenza also changes within not only these major changes from 1918 to 1957, 1968, but also within one of these H1s or H2s, H3s, there are constantly changes going on. And that means that the vaccines have to be changed as well. And for the 2009-2010 season, we have a vaccine formulation now which is being produced by manufacturers, and there is actually a new strain, a new influenza B virus. So for the season which will start in November of 2009-2010, this is the new vaccine formulation. So if we just would live with this, or would only expect these three variants, we would be all happy. But what happened actually in the end of March, April of this year was that a new virus emerged. And that was a virus which actually belongs to this H1 group and is known as either the new swine virus or the Mexican virus. The Mexicans call it an American virus, a California virus. So clearly, this is a new virus, and I think the CDC decided to just call it a new H1N1 virus, H1 subtype of the hemagglutinin, N1 of the neuraminidase, the other surface protein. And then very briefly, in end of April, more cases were confirmed in the US, and then we also found different countries, and 5 countries end of April, and we have several countries beginning of May. And then the WHO, World Health Organization, decided to call this a pandemic. The definition of a pandemic is it's a global epidemic. And as you can see here, we have several countries at the end of April, and then even more countries in May. And then about a month ago, this was called a pandemic, because it was found actually in many, many different countries, and this is sort of going on as we speak. Now, what is this virus, and why is it called basically a swine virus? It is a swine virus because most of its genes, most of these 8 RNA segments actually are derived from swine influenza viruses. In addition, we have also the yellow genes here, which is the PB1, which is one of the RNAs, one of the mini chromosomes that was actually derived from a human strain. 2 other genes were derived from an avian influenza virus, and then 5 genes, 4, 5, 6, 7, 8, were actually derived from different swine influenza viruses. So it's a very complex chimera, and was very, very unusual. If someone would have asked me, and I think most of my colleagues in the field, if someone would have asked me, is that virus, what would be the next pandemic virus, we would never have guessed it would be an H1N1 virus, and one with this curious origin, curious derivation, one from a human influenza virus, 2 genes from an avian influenza virus, and the remaining genes from a swine virus. So this is sort of very unusual. Nevertheless, this virus has sort of hit hard. This shows us the influenza cases in the US, and without going into detail, this is sort of the peak during the January, February, where B viruses are the green ones, the yellow ones are A viruses, and then we have these different H1 or H3. And then very suddenly, in May and April and May, we get suddenly these new H1N1 viruses. Usually we do not have this second peak. It's a virus which is unusual in every respect, that it's an H1 virus and that it also occurs so late in the season in terms of isolates. And the virus is actually quite active. This is a couple of weeks ago. 105 countries already have confirmed this novel H1N1 virus. And these numbers here, total cases, is probably not very good estimates. But clearly, in terms of the total deaths number, this is not probably much higher than we would see with regular seasonal influenza, but nevertheless, this is something to be concerned about. Now, what is also quite unusual is that the immunity, namely that microneutralization tests show that for those 24 years and under, the seasonal vaccination does not produce cross-reactivity. So in other words, people who have been or who are young actually, and even have been vaccinated, they have very little protection against this. On the other hand, people over the age of 60 have been shown to have some pre-existing immunity, and immunity which is able to neutralize this virus. So this is one of the few things where old age really is good in terms of this H1N1 virus. So the older ones sitting around here and standing around here are much more protected. And the reason for that is that this virus, this H1N1 virus, is actually derived from this 1918 virus. So this is the 1918 virus, which gave rise to, on one hand, the swine virus, because the virus really went into the swine population and changed here, and this is a 19% change in the hemagglutinin in the HA1 subunit. And on the other hand, it also went into humans, and we still have H1 viruses, as you remember from one of the first slides, and there we were able to make this comparison, and this shows us that this new swine virus, which is the particular one is here the California virus, is actually closer, or is fairly close related to this original 1918 virus. And so if you look at the genetic distance going from here to, let's say, 1940, you can see that this is much more closely related than to a virus which was in 2007, if the length here indicates genetic distance. So that explains, because the origin of both of these viruses, the swine virus as well as the current H1 virus, is a 1918 virus, and that it was closer if people like me who have been infected in 1945, 1948, so we have more immunity against this new swine virus which has jumped into humans. So that's basically what is happening. There are a lot of studies going on right now, but I want to leave you with three sort of interesting characteristics. The first one is that indeed this new pandemic swine H1N1 virus is an H1 virus, meaning that we all have some cross protection. Obviously the older ones more, but there is still some what we refer to as herd immunity. So we all have some kind of protection. So it is not like an H15 or an H9 or an H5 virus where none of us has any protective immunity against such a virus. In the case of this H1N1, there is some evidence that there is some cross protection. There is also, very interestingly, I mentioned this PB1 gene, one of these 8 RNAs, is missing in terms of one of the proteins, the PB1F2, and it is present in the 1918, 1957, and 1968 virus. But it is not present in the 2009 swine virus. So that, I think, is very good news. And the last point is that it also is sensitive to FDA-approved drugs, namely neuraminidase inhibitors. So I think, yes, it is a pandemic virus which we should be concerned about. But on the other hand, it is not something which has all the virulence genes which we see in other pandemic strains, and we all have some herd immunity against this virus.
Thank you very much.